Hello, my name is Theodora Alishay, and today I will be discussing Lab 2, which deals with lines of charge. Firstly, the purpose of this lab was to create a computational model of two charged tapes which are exerting an electric force on each other, and to use this model to estimate the amount of charge on each tape necessary to float one tape above the other. We also assumed that the charge was evenly distributed across the length of the tape, forming a line charge. The fundamental physical principles that we used in this lab were Newton's second law. For example, we had to determine that the force of the electric force of the bottom tape on the top tape had to be equal to the force of gravity on the top tape, because the top tape is not accelerating. Therefore, the net force has to be equal to 0. Secondly, we used Coulomb's law for a line charge and also the electric field for a line charge, which are both shown in the two diagrams. The main result of the experiment was that the charge of one of the tapes was 18.1973 times 10 to the negative 9 coulombs, and the electric force, which is equal to the gravitational force on one tape, was 1.76582 times 10 to the negative 3 newtons. So in the actual experiment, the system we examined was the top tape, and the surroundings were everything else, including the bottom tape. Initially, the top tape was far from the bottom tape, and the top tape was stationary, but we first created a charge on the bottom tape by rubbing it against another tape, and then we brought the bottom tape close to the top tape, which we had also charged. We found that the two tapes repelled because their charges had the same sign. For my ClosScript model, I created a function that could determine the electric field and another function that could create a line charge. I also had to create the top tape and bottom tape as two objects, and then I calculated the overall electrical force on the top tape by adding up all of the smaller electrical forces for each dq. My assumptions included ignoring air resistance and assuming that each tape had the same amount of charge evenly distributed along the length of tape. The link to my code is at the bottom of the slide. Some possible sources of error for this lab were that measurement of the tape lengths may not have been exact, since I was using a regular plastic ruler, which isn't too precise. And also I struggled a bit to measure the distance between the tapes, which could have introduced error into the lab. If I had modeled each of the tapes as single point charges, I would have gotten a charge on one tape of 9.62 times 10 to the negative 8 coulombs, which is much less than the charge that I got when I modeled them as line charges. These estimates are different because the formula for the electric field of a point charge and the electric field of a line charge are two different formulas. The line charge model is most likely more accurate because in real life, there is a force of an electric field acting on every single surface that is exposed between the two tapes rather than just on a single point. Thank you.